pen is red. It is a Bic ballpoint. The ink is uneven, the way ink gets when somebody has been pressing hard. The paper underneath it is dot matrix printout, continuous fanfold, green and white stripes, a column of numbers and letters running top to bottom, mostly nothing. Most of the column is empty, 2s and 3s. The background noise of an empty sky on a Monday evening in central Ohio, recorded by a telescope the size of 3 football fields, in a cornfield 25 miles north of Columbus. But somewhere in the middle of the page, 6 characters are circled. Beside the circle, in the margin of the page, in the same red pen, somebody has written one word. The word is wow. It is the most reproduced single document in the history of radio astronomy. This is the Cold Archive. Big Ear was not a typical radio telescope. It did not move. The dish, 340 feet wide, made of aluminum panels staked into the Ohio mud, pointed straight up. 40 arc minutes of sky, every second, drifted across the receiver. Whatever the dish caught, it caught only for the time it took the Earth to turn through that 40-minute window. About 72 seconds. The cosmos moves past you. You don't move past the cosmos.
We are listening to a universe whose principal language we do not yet speak. We listen, and we wait, and we wonder.
The signal coming off the dish ran into a computer in a trailer park next to the cornfield. The computer was an IBM 1130. By 1977, it was already obsolete. Ohio State could not afford to replace it. The data came out on continuous feed paper. The SETI program at Big Ear was started in 1973. It had no full-time astronomer. It had a few graduate students who came when they could, and a small group of volunteers who came on the weekends and read the printout by hand, looking for any number above the background, looking for anything at all. Jerry Ehman was 41 years old in 1977. He had a doctorate in astronomy from the University of Michigan. He had been on the Ohio State payroll until 1972, when budget cuts retired his position. He kept volunteering at Big Ear anyway. The work paid nothing. He drove to the trailer once a week, picked up that week's stack of printout, and took it home to read. On the morning of August 18, 1977, he sat down at his kitchen table with coffee and the run from Monday, August 15th. Most of the column was 2s, some 3s. He had read hundreds of hours of empty sky before. Then he reached a column whose first character was a 6. The next was an E, then a Q, then a U. The U meant the signal was 30 standard deviations above the noise floor. In 4 years of operation at Big Ear, no column of data had ever contained a U. He picked up a red pen. Each character in the printout was 1 second of signal. The number or letter was the strength above the noise floor, measured in standard deviations. A 6 was 6 sigma, an E was 14, a Q was 26, the U was 30. In 4 years of running, Big Ear had recorded a few 7s, a smattering of A's. Single-digit letters, weak hits. Nothing higher. The U was new. A signal at 30 sigma above the local noise is not a glitch. It is not a near miss. It is a flag waved at the receiver from somewhere. And the only candidate sources for a flag that bright are celestial, terrestrial, or instrumental. Ehman would need to rule out the last 2 before he was allowed to say the first one.
My first thought was that this was a malfunction. I drove to the observatory the next day to check the receiver. It was working perfectly. That was when I started to be afraid.
The frequency was 142.0.4556 megahertz, the 21-centimeter line of neutral hydrogen, the resonance of the most abundant element in the universe, ringing at its natural frequency. Every SETI program in the world had bet on this channel, on the theory that a civilization trying to be heard would choose the frequency anyone listening would already be tuned to. Ehman pulled the magnetic tapes from the night of August 15. He confirmed the antenna position. The beam had been pointed at a patch of sky near the star Chi Sagittarii. He confirmed there was nothing cataloged in that direction. No nebula, no quasar, no known radio source. The hydrogen line had rung for 72 seconds from a place where nothing was. Big Ear searched the same patch of sky 50 more times in the months that followed. Nothing. In 1987, the Meta program at Harvard searched it. Nothing. In 1995, the Very Large Array in New Mexico spent 14 hours on the coordinates. Nothing. The Allen Telescope Array, the Hat Creek Observatory, Arecibo before its collapse. 49 years of listening. The hydrogen line at Chi Sagittarii has been silent since 1977. The signal was on the air for the 72 seconds Big Ear could see, and then it stopped. Or it continued and the Earth turned past it. Or it was never on the air anywhere else, and only those particular 72 seconds existed at all. We do not know. We cannot ask. Every explanation for the WOW signal lives inside one of three theories, and every theory breaks against one specific constraint. The first theory is the cleanest: a celestial source, a real astronomical object, briefly emitting at the hydrogen line, perhaps a fast radio burst before fast radio bursts had been named, perhaps a magnetar, perhaps something we have not yet cataloged. The signal strength fits. The narrowband character fits. Almost everything about the data fits a real cosmic source. The constraint that breaks it is the architecture of the telescope. Big Ear had 2 feed horns, parallel, staggered 3 minutes apart. As the Earth turned, any persistent celestial source crossed both horns in sequence. The WOW signal hit one, not the other. A real cosmic source at 30 sigma should have rung the second horn 3 minutes later. It did not. The second theory is the easiest to imagine. Earth-side interference. A military radar reflecting off space debris, a satellite passing through the beam, a microwave leak from a kitchen in Delaware, Ohio. 21st century radio astronomers spend half their data analysis filtering exactly this kind of contamination out. The constraint that breaks it is that the signal did not repeat. Whatever was on the air at 1420 megahertz on August 15, 1977, has not been on the air at that frequency since. Earth-side sources, especially the ones in suburban Ohio, tend not to fall silent for half a century. They cluster. They recur. This one did not.
The hydrogen cloud surrounding Comet 266P Christensen would have been near the Big Ear beam coordinates on August 15, 1977. The signal could be cometary.
The third theory is the youngest. In 2017, a planetarium director named Antonio Paris published a paper proposing that the WOW signal was the hydrogen envelope of a then undiscovered comet drifting through the beam coordinates in 1977. The paper named 2 candidate comets. It made the case in a real peer-reviewed journal. It got a great deal of press.
We do not believe the 2 comets theory can explain the WOW signal. The configuration of the telescope should have allowed for a repeat if the source was a comet. There was only one, as if the source was abruptly cut off.
Astronomers responded within weeks. Alan Fitzsimmons, a comet specialist at Queen's University Belfast, pointed out that 1420 megahertz emission has never been confirmed from any comet by any independent observer. Other researchers calculated that the 2 candidate comets were not where Paris's paper claimed they had been in August 1977. The original Big Ear team rejected the theory. And under it all, the same constraint. A comet drifting through the beam should still have rung the second horn 3 minutes later. It still did not. Big Ear was demolished in 1998 to expand a golf course at Perkins Observatory. The dish was cut up for scrap. The trailer was hauled away. The cornfield is now a green in a sand trap and a fairway. The instrument that recorded the most famous signal in the history of SETI was scrapped for a fairway. The data is preserved. The pen marks are preserved. The fan fold paper is preserved. The thing that heard it is gone. The 2 horns, 49 years. The hydrogen line at Chi Sagittarii has not rung again. Sunday's case. The morning of June 30th, 1908. Above the stony Tunguska River in central Siberia, something exploded in the sky with a force estimated between 10 and 30 megatons. It flattened 80 million trees across 2,000 square kilometers. The shock wave reached the barometers of London 4 hours later. A Russian mineralogist spent 14 years trying to get there. When he finally arrived in 1927, he found a forest of upright trees at the center, all their branches blown off, all of them pointing at the sky. He found no crater. He found no fragments. He died in a Nazi prison camp in 1942 with the question still open. The Tunguska event, Sunday 6 p.m. Eastern. See you then.